Ekaterina, what is the biggest challenge in NLP at the moment?
Related to the other questions that we discussed, we think that the most exciting thing that would eventually happen is that we will be able to have a conversation with, for example, an AI agent or an application that will be similar to the conversation that we are having right now. So we're talking to each other, we're human beings, we understand what we mean, and we are able to make inferences, draw conclusions, and so on. So right now, this is one of the biggest challenges in the field because the techniques and the data and the computer power all have brought us to the point where the machines can extract a lot of information from the language data, and they're very good at learning patterns and extracting those patterns so that they can use them to replicate what humans do. So for instance, right now, the AI algorithms based on the NLP techniques can write a whole newspaper article, for instance, and that would be grammatically correct, well-formed, and meaningful. However, where they still struggle is what we would call the natural intelligence. So that is making conclusions based on the inputs in various situations, understanding how to follow up in the conversation in a natural way. So if we're talking about whether we will be able at some point to have a very natural, relaxed conversation with an AI, the main challenge here is can AI actually learn about the inference and learn to make the conclusions based on the previous conversation. So all of these aspects are quite challenging, and at the moment, it's not a solved problem. The second most challenging direction, I would say, is how we can build sustainable natural language processing techniques. And by that, I mean that in the previous years, we have succeeded in building very complex systems that use a lot of data, a lot of power, and they're very advanced, very sophisticated. But right now, there is a certain movement towards how we can actually make it a bit simpler, in the sense that perhaps we don't actually need to invest so much resource into solving some of those problems. So this is a very interesting research question, how we can pretty much get similar results with simpler algorithms. And that also brings us to having more interpretable algorithms, because the more complex are the systems that we are building, the less we can have an insight into what's going on.
Whether machines understand the meaning of what we're saying and can therefore respond by making inferences. And so, is this an external problem to NLP? It pertains to another discipline, or is it a problem of the area of natural language processing? Is there something you do to work on whether machines understand actually the meaning of what is being said, although we should define understand
Indeed.
and respond appropriately? Or is it a problem of another discipline? Natural language processing actually deals with the syntax and form more than meaning formation.
I think NLP deals with the meaning as well. So especially in theoretical linguistics, we are actually talking about what is behind the words. So a word is basically just a form that represents a particular meaning, but what we want to know is what's the meaning behind the sign, which is a word. So I think it's a very fundamental problem, but I would say it's not just a problem in, for example, NLP. So we were talking about multimodal systems. I think making sure that, for example, in computer vision, it's very popular to apply algorithms to distinguish between different objects and recognize the objects in the scene and say, okay, this is a cat, but this is a dog. The question is, does the machine actually understand what is detected? Or is it basically just pattern matching? And the answer is it's pattern matching at the moment. There is nothing essentially sort of profound about understanding that there is a dog in the picture. It's just based on the recognition of the combination of pixels and like shapes around the object and so on. but there is no profound understanding, and there is also no profound linking of how something looks like and what it means and how it's expressed in language, for instance. And this is something that we have, right? When I say dog, you imagine a certain living being. You know how it looks like, you know what are the characteristics, the properties, the dogs bark, jump, run, what they eat, and so on and so forth. But it's something that the machine sort of learns. But if we think about, for example, how we humans learn, we learn much faster from much fewer examples. So as children, we are presented with certain relatively small number of examples of visual information and language, and we during our learning process, we are able to make more extended inference based on what we've seen to actually learn about the whole universe. So this is something that right now machines are not doing. They learn from loads of examples, but basically they learn patterns. They don't learn more abstract representations necessarily as successful as we do.